Hi, everyone at Geeks and Gurus. My name is Melissa Sussmann with Sumo Logic. I'm a lead technical advocate, and with me here is Damian Curry from NGINX.
Hey, thanks for having us today.
Hey, so we're here just to sort of talk about the pillars of modern application and modern app development, and Damian is going to give his expertise on all of that. And then we're going to talk about OTel, Open Telemetry, and essentially how those two kind of fit together.
Yeah, great. Yeah, there's a ton of talk around now about, what is a modern application, and it's definitely something that I've been asked many times. And, the way we always like to talk about it is it's less about it's less about the application. It's about the architecture that you're running and all of the different pieces of infrastructure and other tools that are necessary to run that application. As we've been saying it recently, it's, application is just kind of tip of the iceberg. That's what everybody sees and cares about. But it's easy to forget about all of that underlying infrastructure and tooling that's necessary to make that application run. So we really like to look at it as an outcome based approach. It's not a checklist. It's not, well, I'm running Kubernetes, I'm in the cloud, so obviously I have a modern app. It's all about the outcomes, and the pillars, as you said, are, looking at that portability, the resiliency, and the big things of being able to not only run your app, have it run well and fast and be resilient and fault tolerant and not have easy outages. And in order to get to those places, you need to use this modern technology to, be able to have that CI/CD pipeline and have these instances that are very ephemeral and come up and down. And, if something goes wrong, you're not troubleshooting a server anymore. You're usually taking a container down or even taking an entire site down and spinning it back up. So
Yeah.
yeah, and so it's a really interesting space, and I know, I mean, with Sumo Logic, um, everyone, you're doing a ton of work in that space as well, where NGINX is kind of, gluing together all the applications and allowing that communication and routing of the actual traffic. Sumo Logic is kind of handling the other side of it, right, Melissa?
Yes, I suppose. So to delve a little bit further into just modern applications and architecture, you're talking about portability, scalability, resilience, and agility. There's, observability and monitoring that could be, the fifth and sixth pillars. And yeah, I would say, any analysis type of engine on, data that relates back to logs, metrics, and traces could really fill that need. Um, so how do you see that kind of fitting in with modern applications? Why do modern applications in particular have such a need?
Yeah, I mean, it's nothing new necessarily, right? We've always needed to collect log files and collect metrics and monitoring information, but we've moved away from the older way of doing things where you had, these monolithic applications and these big servers. So you had them, maybe you just had them all on disk, or you're shipping off to one place and you were really scraping for any bit of information you could find, whether it's just looking at, CPU and system level metrics and making sure still have disk space and, the little things like that. And now, as we've gotten into these distributed systems and these microservices based applications, and also probably one of the biggest, it's the older concept, is that, cattle not pets, right? It's no longer these servers that you take care of and they become a part of your family almost, where everything that's running on them. And instead, it's all about being able to tear things down, push out updates, and especially now with Kubernetes and containerization, you may not even have the same container running for more than a couple hours. And when something goes wrong, the benefit is it just goes away. And we're no longer going, oh man, I've got a problem with one server, I got to go fix that. You're going, oh, that container had a problem, it got killed, we spun up a new one, we're good to go, which is great until it comes to troubleshooting. And that's where this observability market is so important, to be able to provide any of the other pillars. Without that observability and knowing what's happening, you can't be portable, you can't be resilient if you don't know what's happening. And when problems maybe just quickly taken out of the mix, there may be a root cause that still needs to be addressed, but it's so much harder to find it because not only are your systems distributed, hell, probably all over the world at this point, you're also dealing with the problem, and the thing that maybe the smoking gun, right, is no longer exists. It's gone. So you need to have something to get all of this information, collect it, and then be able to make sense out of it.
Yeah, so I think also what you're touching upon, so the disparate tooling for more federated models is like one of the things that kind of brings a larger need for not just having a flat interface of logs just like coming in, but rather maybe having some like artificial intelligence or even like machine intelligence that then tells the user or the security analyst or whomever is actually using that, you know, where are things going wrong? How can that data be better enriched? So it's sort of beyond just like we need to know what's happening. It then becomes, a little bit more in the monitoring world of like not what are the things that you can actually do? How can you act upon particular issues that you run
Mhm.
into on these large federated cloud native environments?
Yeah, exactly. And, like we are saying, it's not like you've got a syslog server and I'm going to log in and go grep through a bunch of log files and try to find the problem. Now you've got, so much information. So not only do you need to be able to find what's important, you need to be able to filter out the noise because there's always a lot of that. And then also you need to be able to correlate it. That's the most difficult thing in a lot of times because it's a lot easier because when you had a bare metal system, you knew what was running on that one host. But now, I mean, it was a problem with virtualization and, kind of that noisy neighbor idea where you're going, man, why is this behaving so weirdly? I'm not doing anything. It's like, well, it has nothing to do with that problem that you're seeing. It's actually this other workload that's running next to it that's using up all the resources. So being able to not only have that information and be able to filter it down to something that's useful, but then be able to also associate the seemingly unrelated information that can really point you in the right direction.
Yeah. I think the other sort of like topic here that I feel like you're dancing around a little bit is like not just, the general topics of monitoring and observability, but the idea of like where data is being routed in, where it is streaming, where it essentially comes in and where it goes out. So like the whole telemetry pipeline. What like for you, how would you I like define a telemetry pipeline?
Yeah, and that's always a interesting idea because, telemetry, when you kind of get down to it, it's just information. It's just, all that ones and zeros, and it's the most important thing is having that standard, right? So you have all of this information that may be coming from completely unrelated systems and applications written in different languages, but the fact that it's all coming out in a standardized format and then flowing and having a way to route that information, get it to where it needs to be, and go ahead and actually end up somewhere where it can be processed. So that's where, we start getting into these modern tools that we have where we are getting those standards. And, I think it can go back to, when it was more open tracing or, those tools. And then what we have now being open telemetry or OTel. So having that standardized system so that, you can at least have everything in the same format and have a, agnostic, not platformer or user or, vendor specific format for that information.
Yeah, the information can also vary a lot. It could be container information, it could be region information, GeoIP information, whatever kind of information, logging and trace data, right? And then essentially, for me, the that pipeline essentially, and as far as OTel, where OTel sits on that pipeline would just be where things come in and where things go out. So like import and export. Everything else which
Exactly.
happens in the middle would be more related to like data analysis and processing and a little bit more around like machine intelligence, which I mean, it's great if you have it, but you definitely need to be able to actually like access that data via the same pipeline in a unified format. And yeah, I mean, I guess like even within Open Telemetry, or like the OTel project, you still have like a bunch of other like languages that that things could be instrumented or written in. You could be doing things in Go and Python and C++ and Swift and whatever. So even within that standard, you still have some variability of, in terms of what's supported.
Yeah,
Um,
and even when it comes down to who wrote the implementation, that's what always makes all these things fun too, because like you say, Go and Python, it's not like there's a single OTel provider, right? There's a lot of different ones and things can vary a little bit, but having that standard that everything is trying to share just makes it so much easier, even if, hopefully the information coming out looks the same though.
Yeah. The advantage of Go, of course, is that if you're using Kubernetes, it definitely helps.
Yeah, definitely.
But yeah, so yeah, at least like that's been kind of the cool hip thing that all the kids enjoy using at this moment.
Yeah, and
Yeah.
it's so important, especially in a Kubernetes environment, because like I said, you have those pods coming up and down, and they're all ephemeral. And again, with the whole idea of like a noisy neighbor, that's one of the really interesting things of being able to take all of that information and be able to look and see, like I said, what's happening. Maybe not on the application you think has the problem. It could just be something next door, right?
Yeah. And I think like to dive a little bit further into the problems that you could have, there could also be like in between, the in and out on that pipeline. One of the things you could be checking for would be like security checks or compliance checks, like GDPR and HIPAA. So you're not just looking on that chain. You're not just looking at what's coming in and what's going out. A lot of vendors are also helping with, looking at uh, what is happening with that data, how long that data should be stored. When I say that data, I mean like customer data,
Hmm.
as well as what backend that should go to. So it helps a
Yeah.
lot if you have like a variety of different backends that you're managing, and you happen to be using a language which everyone uses, like Go, and then you're also on a common standard like Open Telemetry.
Yeah, that's actually a really interesting point that a lot of people don't think about, because everybody likes to go like, "Oh, storage is cheap now. Why not? Let's just store everything. Grab all that information, just ship it off." And then all of a sudden you get an auditor coming in going, "Hey, did you know you're probably not supposed to be storing that PII where you have it?" So being able to, again, not only be able to easily store all this information in a single place, but also be able to have an easy way to be able to, not store the information you're not supposed to.
Yeah, precisely. Like, so one of the as far as why this is important, why observability in this kind of environment is important, sort of like a low tech example. I went to the Santa Cruz Public Library because I'm visiting, I guess, like my hometown, and they had like all these Legos, but they looked rather like disjointed. Like some of them come from different worlds or different backgrounds. Abstractionally, you can have like two children playing with Legos. On one side, you have a child creating something that is aligned with like a high fantasy world, and then on the other side, you have someone who's aligned with more of like a sci-fi world. If there's a curtain in the middle and they don't really know, each of them thinks that they're doing something else in a completely different plane of existence, in their mind. Once you move up the curtain, suddenly the two things are disjointed and they don't really fit together anymore. And that
Yeah.
happens a lot. A version of that happens a lot with app developers and app deployments for these modern apps.
Hmm.
Uh, and if you're not on the same observability standard, it's going to be very difficult for security analysts to go across, or even DevOps folks and developers to go across between that curtain,
Yeah.
and just come to an agreement on which standards they're using, which backends they're using, and how that all kind of ties together.
Yeah, I wish I had fewer stories about, all the times when I was running operations or DevOps or whatever you wanted to call it at the time, and we had 4 different monitoring systems because, well, the application guys wanna use this one, and we use this one, and then this other team makes us use that one. So having it to be, even if it's just like, "Hey, we don't care what you use, just do it in Open Telemetry," and then we can at least have consistency. And being able, and I think that's one of the most powerful things, and why I'm so happy to see more and more of these standards coming up in the technology space, is because it makes changing your mind about what specific tools you're using so much easier, because it doesn't matter, you may have the best plan in the world, but in 6 months it's no longer the best plan, and all of a sudden you're going, oh man, now I gotta completely rip out this one piece of infrastructure and figure out how to rewrite everything and do it. But if you're using a standard practice like this, say you can no longer store all the information in house, okay, well now all you have to do is just point your OTel collector at a new endpoint that's external and have a SaaS company take it over, like, Sumo
Yeah.
Logic, for example. And being able to make those changes, because that's one of the really things that's so true in everything, especially in the technology world, is, everything's changing. What is the right answer today might not be the right answer tomorrow. And especially as your environments grow and evolve and change, you may have deployed a observability solution that at the time was perfect, and then another application came along and started piggybacking on it, and another, and now all of a sudden your observability is your bottleneck, which is the last thing it should be. It's supposed to be something that just providing value outside of it, and if it is slowing down your application or your infrastructure, now it's just a liability. So
Yeah.
being able to have that freedom to move where you need to be to support what you have now is so important.
Yeah. Let's actually dive a little bit more into like why people would want to use different backends. Like why is there even this need for an open standard that like unifies all this other stuff? So in our last session of Geeks and Gurus, or well, one of them, the last one I was in, was around gaming for LinkedIn Live sessions. And essentially, you don't want to store user data in the same place that you're running the game. That's like one of the best practices. There obviously are things like GDPR requirements and FedRAMP requirements for other stuff. But in gaming, one of the most important ones is COPPA, which is like a Children's Online Privacy Protection Act. So teams will be working, with personally identifiable information of children, often in the gaming industry. And they have to think about, where that data is stored, who should have access to it, and there are also going to be limits as to where that telemetry data is also stored. This also happens with like social media accounts, things like that, and also when that data has to be deleted. So all of that has to be like regulated.
Yeah, and again, just to trying to figure out what you should store, what you shouldn't store, and again, like you said, the performance too, because if you're storing that information in the same place you're storing the in-game information, it's, well, now you're just created a giant bottleneck in your own place. So yeah, having that ability to chunk information to where it needs to be and where it makes the most sense to keep it is a very, very powerful tool, especially as things are ever growing and changing, and you need to be able to keep up with the load and the information that you have coming at you. And it's one of the other reasons why, while open telemetry is a great thing, it also causes problems and it requires other tools. Open telemetry by itself is just bunch of strings of random characters, right? Until you have something that can look at that information and make sense out of it, it doesn't do anything for you. So you really need that observability part, where it's not just the traditional kind of monitoring that we always used to talk about. It's logs, it's the application tracing, the metrics from the systems, how many requests you have coming in. It's all of this information put together, and then trying to distill it down to something that's actually helpful rather than just noise.
Yeah. I think that's a good point. Obviously, you have analysis that basically happens between data coming in and out of the pipeline. It's just nice when everybody's on the same playing field, so to speak. There's a lot of like building of Legos that happens. But as long as you're on the same like sphere, or you're on the same plane, uh, or the same like sort of like fantasy world or whatever, as goes with the previous analogy, it makes everything else a lot easier. It makes it a lot easier for developers to do things like shift left in their organization as well. Um, yeah,
Yeah, and I think it's funny. Open telemetry is kind of a good example of that kind of progression of a tool. It's not something that just kind of was created out of nowhere. It kind of came from these other tools where you had open tracing that was that, pretty much, very application tracing focused. And then you had open census, which was a little bit more metrics, but also some tracing there as well. And then thankfully everybody got together and went, hey, we have these two different solutions that are doing mostly the same thing, but they each have some upsides and downsides. Let's make a real standard, right? It's no good if you have 25 different standards, because, well, then there's really no standard.
Right. It is nice having a unified mechanism for approximating system-wide health, just for everything to make sense. I think that, like, another sort of challenge that I've noticed, sort of culturally, that happens within organizations is, again, in that shift left model. Basically, if a developer feels that they have no incentive to actually, like, influence the deployments due to a lack of monitoring or a lack of understanding around the system-wide health, they then feel like, "Oh, well, I don't actually think that I need to do anything,
Hmm.
to help with the security or to help with deployments to come out like more smoothly," because they don't like working around a black box. No one likes working around a black box.
Yeah. Yeah, it's the classic, operations versus development, right? You got you're always going to blame each other unless you can have, accountability, which is something that it kind of provides and lets you go, well, actually, if we look at the tracing information, we can see exactly where the bottleneck is. And oh, look, it is a little bit because of the system health, but it's usually never one team's fault or the other. It's usually a combination of both. And, having that more firm information to be able to go, no, this is what actually was happening when we had that issue, and really being able to not, in a way of, being able to put blame on one team or the other, but to find a solution to the problem. I mean, because at the end of the day, that's really the important thing, is being able to solve these problems that come up when you're running these large distributed systems.
Yeah. I mean, I think you don't have to necessarily be like a experienced, Go developer to understand a lot of these concepts. I think the primary thing for me is just like, in any organization like that, that you address those cultural problems by also having a unified system. And even despite the issues that one might have with the way in which we came to a unified open standard, uh, the great thing about standards is that there's so many of them.
Hmm.
Uh, despite all of that, at least it should help have, solidified best practices across dev and ops.
Yeah, yeah, definitely. There's a lot of the best practices, and just being able to compare all of that information, and like you said with the shift left, I think that's one of the big things, whether it's security or, in those states, it's no longer, oh, well, that's operations job to figure out, that's SecOps job to figure out. It just, no, it's everybody's job. Security is applied at every level instead of just the very end, right? It's not something that gets duct taped on at the end. It's something you got to be thinking about all through it, as I'm sure everybody is used to hearing now with all supply chain attacks, that supply chain, and having that idea that it's everybody's job to worry about that security or that tracing, and just being able to make sure that we leverage the tools that we have to be successful.
Yeah, makes sense. So, app supply chain attacks. Like, what are some examples of that?
Well, the supply chain attacks are really interesting, and it's something that's been coming up more and more. Where, if you've been following and all the things that have been happening with npm and the different packages, it's become so easy when you're writing applications to include these other packages. Well, that packages includes a package that includes a package that includes a package, and now you're getting these 5 layers deep, where it's happened, and will continue to happen, that it's easy to fit an exploit into one of those downstream packages that is malicious, and maybe was part of an actual legitimate patch, but somebody hid a little piece of code in there. And when
Yeah.
these things just get included and included, it's really hard to tell when something breaks, like what actually broke. There's the infamous, what was it? I think it's the left arrow or left pad. It was a very, very small package. It's like, under like 20 lines of code, and it's an npm package that just gets included in all of these other ones. And there was a fight between the founder of it and the people behind npm, and the founder removed the package. All of a sudden, Facebook went down. Every websites
Yeah.
across the internet just disappeared because of 14 lines of code or something like that disappeared. And it's something that wasn't even being included directly. It was a dependency of a dependency. So this idea of being able to, needing to be, cognizant of that, and really looking at not just what code you're writing, but what code are you including to write your code, and being very cognizant of that. It's a really interesting space. So there's a lot going on in.
Yeah. A while back, I was looking at like mods for different games, and I'm always a little wary of downloading mods. And like,
Mm-hmm.
oh, it's open source and like it's fine. You can see if there's any kind of like attack packet or whatever. But I mean, like you were saying, it could be a dependency on a dependency on a dependency. And
Yeah.
who really has time to go through all of the details that occur within mods?
Yeah.
Uh,
And there can be
when you're
so
just
much
like,
it's a legitimate package, but there's this little tiny chunk of code that you don't realize just opened up a backdoor in your entire application.
yeah, exactly. It's
So
definitely one of my concerns.
yeah, it's definitely an interesting place out there now, and at least it's getting some attention now.
Yeah, that's true. So I think we're coming up on time, but I think I'd like to just kind of we can leave some time for questions as well, because on this side there's going to be people also asking questions. But it's been really enjoyable having you here with us, Damian.
Yeah.
And this has been a really fun session.
Yeah, definitely. Thank you so much for having me, and yeah, it's always fun to nerd out on stuff like this.
Yeah.
All right.